Hello all. In this video, we'll learn about the demonstration of company database. So in this relation schema, we have got 5 entities, 5 tables. That is employee, department, department location, project and works on. As you can see in employee table, we have got 7 attributes. Here SSN is a primary key, and department we have got 4 attributes, and department number is a primary key. And the department location we have got department number and department location as a primary key. And in the project table, so we have got project number as a primary key. Yes, in the works on table we have got SSN and project number as a primary key. So here we got 5 queries. Okay, so let us first create the employee table. Yeah, this is a relation schema. As you can see here super SSN here is a foreign key that refers the primary key, and here department number is a foreign key that refers to the department number of D number of department table. Okay, and here we have got in the department table we have got manager SSN, so it's a foreign key that refers the SSN from an employee table. Yes, now let us create a table. Now to begin with, we'll be just beginning with creating a department table. So as you can see, why we have to begin with department table here is, so as you can see here, yes, as you can see the department number is a primary key, department name and manager SSN. Here manager SSN is a foreign key, so we have to skip this manager SSN. So since it is a foreign key, so we cannot create a foreign key before primary key. So here this foreign key manager SSN is a child key and SSN is a parent key. So first we need to create a parent key, and after that we need to create a child key. So yes, so whenever we create a department table, here we just create department number, department name and manager start day. We'll be just skipping manager SSN. Yes, as you can see here we have just created table, department table, department number, department name and manager start date. So we have just skipped manager SSN. So by making use of alter command, later we can add this manager SSN once the parent key is created. Okay, now let us create employee table. Yes, again as you can see here, yes, now let us create an employee table. So SSN variable character primary key. Yes, we have just divided this name as first name and the last name, address, the sex, salary, super SSN and department number. Okay, then the foreign key, here we, as you can see here, super SSN is a supervisor of a particular employee. So this is a foreign key, refers the SSN from the same table. The super SSN refers the SSN, here SSN is a primary key. Okay, so references employee SSN, and we have got foreign key department number references from department table. Okay, as you can see here, this employee, the department number in an employee table refers the department number of a department table. Okay, yes, thus we have just created department and employee, and as you can see here, now we can create manager SSN because we have just created SSN attribute has been created, that is parent key has been created. Now it's time to create the child key. So by making use of an alter command, we can add manager SSN to the department table. Yes, let us see how to add manager SSN to the department table. So this is a command, alter table department add manager SSN and the data type. Now once we have added this manager SSN, now we need to add the constraint for that particular attribute. Yes, we can add the constraint using alter command, alter table department add constraint, fk is the constraint name. Okay, so we are just adding the constraint called as foreign key, and here fk is the constraint name, and then we can add the, yeah, then this is what foreign key manager SSN refers the SSN from the employee table. Yes, so this is how we just added this manager SSN using an alter command. Yeah. Next we'll create department location. Yeah. Yes. Department create table department location. Here we just created D location and department number, and here yeah, department number is a foreign key. As you can see here, this department number is a foreign key that refers the D number from department table. So foreign key department number reference D number of department table. Okay, and here the primary key is combination both department number and department location. So this is primary key is a combination of both. Okay. Yes. The next is creation of project table. Okay. Yes, as you can see here, project number is a primary key, and here in project table D number is a foreign key that refers to D number of department table. Here the D number of a project table is a child key, and D number of a department table is a parent key. Okay. Yes, so create table project number integer, project name variable character, project location, and department number variable character. Yes, this is how you make project number as a primary key, and to make this as a foreign key, keyword foreign key department number reference department D number. Yeah, that's it about a project table. Yes, now let us look into works on. Yeah, now let us create a works on table. As you can see here, SSN and project number, combination of SSN and project number is a primary key. This is what is given, and here SSN attribute is a foreign key that refers the SSN of an employee table. Okay, so as you can see, this refers the SSN of an employee table, and the project number refers this P number of a project table. Okay. Yes, let us create the table. As you can see, create table works on hours integer, SSN variable character, project number integer, and as you can see here, SSN is a foreign key refers the employee table. So here this SSN here is a parent key, and we have got a project number references P number of a project table, and the combination of both as a primary key. That's it about creation of table. Now let us look into how do we insert the data into the database. Yeah. Yes, to begin with, yeah, just we need to insert into employee table. Okay. Yeah, to insert into an employee table, let us look into the relation schema. So the why we have created department table first was why we skipped manager SSN, because manager SSN was a child key and SSN was a parent key. So parent key was, we cannot create a child without a parent, so we just skipped this manager SSN. Initially we just skipped this skipped manager SSN. We have just added department number, department name, and manager start date. After creating employee table, later we created manager SSN. So this is just because the simple logic is that before creating a child key, you need to create a parent key. Okay, the same way we need to follow the same rule when we insert the data. Okay. Yes. Now when we insert, yes, let me let's say I have got SSN. Let's say I have got an employee with SSN 100. Okay. Let's say we have got first name, some XYZ, address, some random place, some gender and salary, and let's say the supervisor of this employee with the SSN 10, let's say assume it as it is 25. Let's say supervisor of the employee with the name 10 is 25. Okay, now, and the department number is 5. Now I cannot insert the data to this employee table because here, as you can see here, 25 is a supervisor. Here super SSN is a child key. So this super SSN value refers from an SSN table. Now when I insert for the first row, when I try to insert for the first row, my first row employee SSN of a first row is 10 and the supervisor of that 10 is 25. But we have got a constraint, that is here super SSN is a foreign key that refers the value from SSN. So here it is a violation. If you try to insert this, it will throw an error. It's a violation of referential integrity because we don't have an SSN with the name 25 as in the first row. So for that, what we have to do here is same applies to department number also. Let me assume I'm trying to insert for the department number, but let me initially first I'm trying to insert for an employee table and try 5 as department number, but I have not inserted the value 5 for the department table. For the parent key, the value has not been inserted. Again, this is a violation of, these two will be the violation of referential integrity. So for that, we'll be just initially when you add, we just skip these two attributes. We'll be just skipping these two attributes. We'll be initializing to SSN, first name, last name, address, sex and salary. After that, we will insert to the department table, and finally we can get back to this using update command. We can update the value of employee, update the attributes of super SSN and department number. Okay, let me explain it in detail. So initially when I insert the data, initially when I insert to the employee table, here I have just skipped supervisor SSN and department number. I am just inserting only for the SSN, first name, last name, address, sex and the salary of an employee. Okay, the same way. Okay, after that I will be inserting for the department table. As you can see here, I will be just inserting for the department table. Again, as you can see, I have just insert for the department table. Okay, and once insert the value for the department table, I will go back to the employee table where I update the supervisor SSN and department number. So this is how I go back, because I have to use update. Once again, I cannot use insert, I need to use update. Okay, so update what? Supervisor and department number. Update supervisor and department number using update command. Okay, so this is how this is to avoid the referential integrity error. So this is how we need to insert the data to the employee and department table. Okay, so we'll understand this much more clearly in the demonstration. So at the end of this explanation, we'll demonstrate this entire query. Okay, so let us understand about the first query. Okay, make a list of all project numbers. Make a list of all project numbers for projects that involve an employee whose last name is Scott, either as a worker or as a manager of the department that controls the project. Here, there are many number of employees with the last name Scott. There are many number of employees with the last name Scott. They can be either as a worker, they can be a manager. Okay, so what I want is, I want the list of project numbers where an employee Scott is working either as a manager or as a worker. Okay, yes. Now first, as you can see here, first, how will I come to know whether Scott is a manager or not? Yes, anyways, Scott name is available in an employee table, so we need employee table just to identify whether Scott is manager. How will I come to know whether that particular person is manager or not? See, using this employee table name, I get the information of the Scott. Using employee table, I can get the information. I can get the SSN of Scott. Yes, using the department table, using manager SSN, I can check whether the Scott is manager or not. and thus using a project table, I can just retrieve the project numbers of an employee Scott as a manager. Okay, so yes, we'll go back to the query now. Yes, as you can see here, select project number from project, department number and employee. Yes, and how would you join these two tables? How would you join employee and department? Using SSN is equal to manager SSN. How do you join it with the project table? Using department number is equal to P dot department number. Yes, as you can see here, we have used project, department and employee, and this is how you made use of a join condition. And yes, this is what has been asked in the question. The last name should be is equal to Scott. So this overall, this subquery says that retrieves those information, retrieves those list of project numbers that involves an employee whose last name is Scott as a manager. So this is about the as a manager. Now next subquery, yes, using union operation. So this subquery returns those project numbers, returns those project number where Scott is a worker, just as a worker, and then perform a union operation. Okay. Now how will I find whether the Scott is worker? Yes, that information is available in a works on table. Okay, we just make use of works on table and employee table and join that, and then in the where condition we need to provide the last name is equal to Scott, and this is how you join the tables. That is p1 dot project number is equal to w dot project number, and e1 dot ssn is equal to w dot ssn. So this is how you join these two tables. So this is thus the first subquery says that this is a project number where Scott is a manager, and the second subquery retrieves those project number where Scott is a worker and then perform a union operation. Thus we'll get the final result. The final result is nothing but we'll get a list of project numbers that involve an employee whose last name is Scott, either as a worker or either as a manager of the department that controls the project. Yeah, that's it about the first query. Yes, we'll look into the second query. Yes, show the resulting salaries if every employee working on IoT project is given a 10% rise. Here, what is IoT? IoT project is project name. Project name is IoT. And salary, where is a salary? So I need for project name is IoT, so I need project table here. Show the resulting salaries. I'll be updating the salaries, so I need employee table. Okay, so the employee those are working in IoT, I need to just update the salary by 10%. So which means I can just perform a multiplication operation to the salary, that is 1.1. 1.1 is nothing but 1.1 into salary is nothing but salary plus 10% hike of 10% of that salary. Okay, so yeah, this is what I've given an alias name to that particular column, and this is what I'm going to retrieve. Select first name, last name and their salary. The salary is nothing but updated salary. Okay, next is from employee works on project. Yes, I need works on also. Yes, I need works on also, because I'll be just combine. I need to know whether the employees are working or not. Okay, and yes, I need to map. As you can see in the works on, we have SSN and project number. Okay, so I need works on also, so I'll be joining employee and works on using SSN, and I'll be just combining it with the project using project number. So as you can see here, employee.ssn and works on.ssn and project number is equal to w dot project number is equal to p dot project number, and finally project name is equal to IoT. Yes, so this query thus returns the employee name, that is first name, last name, and the salary, where the salary with 10% hike. Yeah, that's it about the second query. Yes, let us look into the third query. Find the sum of the salaries of all employees of accounts department, as well as the maximum salary, the minimum salary, and the average salary in this department. Yes, so in the question it has been asked clearly that we need to make use of aggregate functions. So which are those aggregate functions? Sum, max for maximum, min for minimum salary, and avg for average salary. And what is accounts? Accounts is nothing but the department name. Yes, so here since salary, I need to update the salary, so I need employee table. Since department accounts is nothing but the department name, I need department table. Yes, that's it. As you can see here, sum of the salaries, we need to find the sum of the salaries. Here sum is an aggregate functions, max that returns a maximum salary and minimum salary and average salary of all the employees who belongs to department number accounts. Okay, and yes, and how do you join employee and department? Using department attribute. So e dot department number is equal to d dot department number. Yes, that's it about the third query. Now look into the fourth query. Yes, let us look into the fourth query, that is retrieve the name of each employee who works on all the projects controlled by department number 5. Yes, in the question they have asked to use not exist operator. Yes, well, if the subquery, what is exist operator? Well, if the subquery returns true, which exist will return true. If subquery doesn't return any value, then not exist will return true. Okay, so we need to retrieve the name of each employee. So we need yes, employee table, because we need to retrieve the name of each employee who works on all the projects controlled by department number 5. Yes, as you can see in the project table, we have got department number that controls some projects. Okay, let's say yeah, as you can see in the question they have asked, projects controlled by department number 5. As you can see here, the department number 5 here controls some of the projects. Let's say the project number is 1 and 2. Okay, here let's say the department number is controlling the project number 1, and let's say it has been 2. Okay, so how will I come to know that? I want to retrieve the name of each employee who works on all the projects that controlled by department number 5. So I want to, in reality, I want those employees who work in the projects 1 and 2. So which one table do I require? I require employee table, project, and works on. Okay, so here, yes, so yeah, let me look into the query now. Yes, select first name and the last name. Okay, from employee table, and this is what has been asked in the question. We have to make use of not exist operator. Okay, and yes, now what we have to use is select project numbers. So where department number is equal to 5, that's it. This is our select project number from project table where department number is equal to 5. Okay, the next thing is, let's say 5 is monitoring, controlling project number 1 and 2. Next is, I want to identify the employees who work in both 1 and 2. So for that I need works on table. So project number not in, select project number from works on where e.ssn is equal to ssn. So that is nothing but e.ssn is employee ssn, and yes, this ssn belongs to works on. So this finally, the result is nothing but it's a list of names of employees who works on all the projects controlled by department number 5. Yeah, that's it about the fourth query. Hello all, in this video we'll demonstrate the execution of queries in employee database, company database. Yes, we have got in company database we have got 5 tables. So in employee table we have got SSN as a primary key and super SSN and department number as a foreign key. And as you can see here, department number is a foreign key that refers the D number of department table. So here the D number of department table here is a primary key, and department number in employee table is a foreign key. So yeah, the one rule is before you create foreign key we have to create primary key. So primary key here is a parent key, and foreign key is a child key. So the parent key has to be created first before the foreign key. Okay, same like for example, yes, in case of as you can see here, manager ssn is a foreign key, refers ssn of an employee table. So before you create manager SSN, we need to create SSN. Simple as that. And when it comes to department number, before creating department number, we need to create this department number of department table. Because here in department number in department table, this is a primary key. Yes. So now let's see how we can execute how we create this table. Yes, we cannot directly create employee table, as you can see that here department number is a foreign key, and also I cannot directly create department table because manager SSN is a foreign key. So here manager SSN is a child key and parent key is SSN. So I cannot create employee and department directly. So one thing what I can do here is I will just begin with department table, but I will skip manager SSN. Okay, I'll just skip this attribute. I'll be adding it later using alter command. First I will add department number, department name and manager start date. Yes, yes, we'll directly execute the query now. Yes, let's type the command mysql -u root -p. Yes, and yeah, let me display the databases available. The command is show databases. Yes, it will display the databases available. Yes, now I want to create a new databases. Let me say it as EMP. I will just name the database name as EMP. Okay, create database. Yes, EMP. Yes, create database, and EMP here is database name. Now let me type the command show databases. Yes, as you can see that EMP database has been created. Now out of these so many databases, I need to make use of EMP database. So the command is use EMP. Yes, now yes, as you can see the database change, which means whatever table which I create will be stored under EMP database. Okay, now I just begin with create a table. Okay, I'll just create a table. I'll just copy paste it. This is just a demonstration, and just paste it now. Yes, and let me describe the department table. Yes, as you can see here, have not added manager SSN because manager SSN was foreign key, and SSN was primary key of an employee table. So that's the reason I've not added it, because the parent key has not been created. So next what I'll be going to do here is I'll be just creating the parent key now. Okay, that is, sorry, employee table. Okay, so yes, going back to the create table, just copy this. Let me copy it and paste it. Yes, so Let me describe employee table. Yes, as you can see here, I've just created a SSN. Here SSN is a primary key and super SSN and department number is a foreign key. So next what I can do is now I can add manager SSN to department table. I can add manager SSN to department table using alter command. And I can also add the constraints. I can make that manager SSN as a foreign key using alter command. Okay, so yes, let me copy this alter command, just copy it and let me paste it to the terminal. Yes, I've just, as you can see here, alter table department, add manager SSN. So yeah, let me describe now department table. Yes, now as you can see the manager SSN attribute has been added. Now as you can see here, we have not added the constraints. Now we need to make this manager SSN as a foreign key. So we need to add the constraint here. So we have got alter table, just copy it and paste it. Yes. Yes. Now let me describe the department table now. Let me describe the department table. As you can see here, manager SSN is a foreign key now. Okay. Yes, now just we have done creating with department and employee table. Now let me create the department location and yes, department location, project and works on table. Let me copy paste it together. Yes. Now to see number of tables have been created, the command is show tables. Okay, yes, as you can see the department location, employee, project and works on table has been created. Yes, now let me insert the data to an employee table. Yes, when you insert the data to the employee table, okay, so we'll be just inserting to SSN, first name, last name, address, sex and salary. We're not going to insert for super SSN and department number because both are foreign keys. Okay, so we'll be inserting it later using the update command. Okay, so now just copy it first data, let me copy it and paste it. Yes, so now if I type the command select star from employee, as you can see the data has been created, and as you can see the attribute super SSN and department number will be null. So we can update these fields later using an update command. The reason we have not inserted the value to super SSN department number is because these two are foreign key. Okay, these two data are foreign key. Okay, now let me insert it some other data. Okay, I just copy paste some other data. Yes, copy and paste it. Let me insert all the data. Yes, now if I type the command select star from employee, yes, so these are the datas, and you can see that super SSN and department number we have not yet entered. So yes, now we'll be inserting a value for the department table. As you can see the department number here is a foreign key, and the primary key, and this department number refers the d number of department table. Now I need to insert the value for the department table. Yes, now I'll be just inserting the value for the department table. Yes, just copy it and let me paste it on the terminal. Yes, now type the command select star from department. Yes, as you can see here, these are the data of a department table, and as you can see department number is 1 2 3 4 5. Now I can just update this department number of an update the department number and super SSN of an employee table. So how can we update? The command is update employee set super SSN is equal to null and department number is equal to 3, where SSN is equal to yes RNSEC so and so. So why this null? Because some employee may not have a supervisor, so that's the reason we keep it as null. And for some for some employees, that some SSN has supervisor, as you can see here. Okay. Yes. Now let me update all the attributes of super SSN and department number. Yes. I just copy and paste it. Yes. Now let me type the select star from employee. Yes, as you can see here, the super SSN, supervisors SSN and department number has been attributes has been updated. Okay. Yes. Now let me insert the values for the department location, project values, and works on table. Okay. Let me copy and paste it all together. Okay. So select star from employee table looks like this. Select star from department table, yes, looks like this. And select star from delocation table looks like this. And select star from project table. Yes, this is a project table. And the last one is works on table looks like this. Yes. So we just created the table and we have inserted the value to all these table. So the next step is we'll demonstrate the working of the queries. Yes, we have the first query is about make a list of all project numbers for projects that involve an employee whose last name is Scott, either as a worker or as a manager of the department that controls the project. Yes, as you can see here, this subquery is retrieves this project number where Scott is a manager, and this subquery retrieves this project number where Scott is a worker, and just perform a union operation with both these subqueries. Yes, now just copy and paste it on the terminal. Yes, as you can see here, we have just got project number 103 and 102. Yes, so this is an output project number 103 and 102. As you can see here, we have got two employees with the last name Scott, that is Edward Scott and John Scott. Okay, and their SSN is 3 and yes, CSE 3 and ECE 01. And yes, to which CSE 3 and EC01, that is 102 and 103. Yes, 102 and 103 is an output. Okay, as you can see here, CSE01 and ECE01. So this is 102 and 103 is an output. Okay, yes. Now yes, show the second query. Show the resulting salaries if every employee working on IoT project is given a 10% rise. Yes, just copy and paste it. Yes. Now yes, as you can see here, let me go back to the query now. Show the resulting salaries if every employee working on IoT project is given a 10% rise. So I just want those employees who work in IoT, and I want to increase their salary by 10%. Okay. Yes, now just let me go through this data. Okay, first of all, I just want to know department table. Yes, department IoT. Do we have the project name IoT? Yes, we have got the project name IoT here. Yes, what is the project number of IoTs? That is 100. Yes. Now I just want to know the employees working under this IoT projects. So as you can see here, these are the employees working on IoT projects. Okay, so as you can see, the project number 100 is IoT, and these are the employees working on IoT project. And what I want is I want to increase their salary. Let me take one example as CAC04 is working on IoT project. Now let me see who is CAC04. Yes, the Pavan Hegde is working on IoT project. Now his salary, I need to increase it by 10%. So we have got 65, what is this, 6,50,000. So what is 10% of 6,50,000? So 10% of 6,50,000 is nothing but 65,000. Yes. Yes, let me look into this. Pavan Hegde, as you can see here, his salary has been increased 7,15,000 after the 10% rise for his salary. Yeah. Yes. Let us look into the third query. Find the sum of the salaries of all employees of the accounts department as well as the maximum salary, the minimum salary, and the average salary in this department. Yes, there is a department name called as accounts. I want, yes, I want those information of an account departments, employees working on account departments, especially salary. I want those employees sum of the salary who works in employee department, the maximum salary, minimum salary, and average salary. Yes, we have made use of an aggregate functions to just to find those the sum of the salary, maximum, minimum, and average salary of the employees who working on accounts department. So let me copy and just paste it. Yes, so the sum of the salary is yeah, 65,000. No, is it 6,50,000? Maximum salary is yeah, 3,50,000, and minimum salary is 3 lakh, and the average salary is 3,25,000. Let me check, verify this data. Department name should be accounts. So department, where, let me go to the department table. We have got accounts, and the department number of is 1. And let me check these two data. As you can see, Ahana K and Santosh Kumar belongs to accounts department. Yes, as you can see here, the sum of these two is 65,000. What is that? 6,50,000, and minimum is 3 lakh, and yes, maximum is 3,50,000. So this is what we got the answer. Yes, maximum 3,50,000, minimum 3 lakhs, average is 3,25,000, and the total of 3 lakhs and 3,50,000 is 6,50,000. Okay, let me look into the fourth query. Retrieve the name of each employee who works on all the projects controlled by department number 5. So yes, let me copy paste it. Yeah, and paste it over here. Yes. Yes, so James Smith. So this is an employee who works in all the projects controlled by department number 5. Okay. Yes. The next fifth one is, for each department that has more than 5 employees, retrieve the department number and the number of its employees who are working more than 6 lakhs. Yes. So once again I repeat, for each department that has more than 5 employees, retrieve the department number and the number of its employees who are making more than 6 lakhs. Yes, for that, yes, what we want is for each department who is working more than 5 employees. As you can see here, we have made use of the subquery. So we have just grouped based on the department number, and we have made use of having clause, and condition on a group is that count should be greater than 5. Yes, now let me copy this and paste it. Yes, there you go. So this is the department number 5 and count is 3. So yes, so we just retrieve this department that has more than 5 employees, and we just retrieve the department number and the number of its employees who are working more than 6 lakhs. Yeah, that's it in this video. Thank you so much.